Alright guys, this video is lesson 39, slope fields, which is your other 38. So back in chapter 25 we studied simple differential equations. Those were equations that were dy dx. And what you did was you took the antiderivative and found y equals as the expression. But since we didn't know if there was a constant, because the derivative of a constant is 0, when we took the antiderivative to find the equation, our solutions always had the expression plus c on it. So consider the differential equation dy dx equals 2x. We know that that's going to be y equals x squared plus c if the derivative is 2x. This represents an infinite number of solutions because c could be anything. So no matter what the value of c is, when we take the derivative, we are going to get dy dx is equal to 2x, and we can view that equation, we can view the equation dy dx equals 2x with something called a slope field or a direction field, which looks like this. The slope field shows the slope of the solution to the differential equation at any point. So at any point, at any ordered pair, the slope field shows the slope of the solution to the differential equation. So it's the slope of the tangent line to that solution, to that equation at any point. So let's say, oh, and also see how kind of your eye here is telling you that the solution is a quadratic. It could be a quadratic up here, over here, over here. You know, it's a quadratic plus c. C could be positive, which moves it up. C could be negative, which moves it down. So these are all the possible x squares plus c's. So what if the solution goes through the point -1, -1? So if the solution goes through the point -1, -1, then -1 is equal to -1 squared plus c, which makes -1 equal to 1, plus c, which makes -2 equal to c, which makes the parabola y equals x squared minus 2. X squared minus 2, because c is -2, which is right here. X squared minus 2. But you don't have to do all this stuff, because all you have to do is find -1, -1, plot it, and then follow the slope fields. It's going to push you. You got to go through this point though. It's going to push you. The slope fields are pushing you up and over to make the parabola x squared minus 2. So it's really easy to create slope fields. It is time consuming. It was on the exam last year to create a slope field. Usually they don't ask you for too many points, but it's pretty easy to do. So here's how you create a slope field. Remember that dy dx is the equation for the slope of the tangent line at any point. So we are going to create a slope field for dy dx is equal to y. We're going to graph that slope field, and then we're going to trace the particular solution at 1, 1. And then you're going to do the rest on your own. Okay, so dy dx is equal to y. So that means that no matter what, the slope is equal to the y value. So at the point 2, -2, dy dx is y. Y, 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 and y. At the point 2, -1, 1, -1, and so on and so forth, the slope of the tangent line is -1, -1, -1, -1, -1, 0, 0, 0, 0, 0, and so on and so forth. Okay, so let's create a bunch of slopes. At the point 2, -2, the slope is -2. So at the point, so I'm going to graph a little line with a steep negative slope. Steep, 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 steep for all of these ordered pairs. 2, -2, 1, -2, 0, -2, -1, -2, and -2, -2. So now at the point 2, -1, I'm graphing a slope of -1, which is a little less steep, more horizontal, for the ordered pairs 2, -1, 1, -1, 0, -1, -1, -1, and -2, -1. At 2, 0, 1, 0, 0, 0, negative 1, 0, and negative 2, 0, the slopes are all 0. At 2, 1, and all these, the slopes are all, at these points, the slopes are all 1, so positive. And then the other ones are 2, so more steep. Should go through those points. I don't know why I'm missing them. There we go. Okay, so there is our slope field. All right, so there's our slope field. I fixed those. And now we want to approximate the solution passing through the given point. The given point is 1, 1. So let's find 1, 1 on here, which is right there. And we want to approximate the solution passing through the given point. So it looks like the slopes are pushing me that way. And that is how you do the problem. That is how you create a slope field. And then you find the given point, plot it, and have the slopes push you in the direction through that given point. So I would like you to do the slope fields for 2 and 3. Again, let me set up number 2 for you. dy dx is x plus y, so for all of these slopes, you're adding x and y. So for the point 2, negative 2, you're adding 2 plus negative 2 to get you a slope of 0. For the point 1, negative 2, you're adding 1 plus negative 2 to get a slope of negative 1, and so on and so forth. So that means that at 2, negative 2, I have a slope of 0. At 1, negative 1, I have a slope of negative 1. At 0, negative 2, I have a slope of negative 2. 0, negative 2, 2, negative 2, 1, negative 1. This is x, and this is x, and this is y. All right, so 0, oh, I already got 0, negative. 0, negative 2, I have a slope of negative 2. And negative 1, negative 2, I have a slope of negative 3. Negative 1, negative 2. Oh, I graphed this one in the wrong. That's the problem. Okay. 1, negative 2, I have a slope of negative 1. There we go. Goodness gracious. Then this one's slope is negative 3, more steep. And this one's slope will be negative 4, which is even more steep. That's hard to do. All right. And you get the drill. Hopefully that made sense. You're finding these slopes by plugging x and y into the dy dx formula. You build your chart of slopes. You graph each slope at the ordered pair in question as best you can. And then we're going to do the particular solution through 1, 1. Actually, if you can complete the classwork and for slope fields, so complete the last 2 classwork problems and these 4 homework problems so that you experience those, and then check your answers right at the beginning of class tomorrow so we can move on to the next lesson, which is separable diffie Qs. Thanks, guys. Bye.